All right, let's open up to page 351. We're going to finish this table we were filling out yesterday. I believe we still have the last one to do. Before we do that, though, Disney people, I had some students come up to me and ask for the worksheets that we did in class while you were gone, because some people wanted extra practice. If you want a copy of those worksheets, can you just raise your hand so I know how many I need to make? Basically everybody. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, sounds good. I'll have those for you tomorrow, all right? All right, so yesterday we were taking a look at the inverse relationship between exponential functions and log functions. We analyzed graphs, how we can switch the numbers in the ordered pair. We looked at functions, how we can switch the x and y variable to help us find an inverse equation. And we left off yesterday filling out this table, trying to show the relationship between domain and range and asymptotes and how everything's kind of connected. So, what I want you to do, because we did the first two together yesterday, I want you to try the last one. Okay, we're looking at the -3 to the power of x minus 2 and then plus 1. Try to fill out every single column. The inverse equation column, the middle one, comes from the previous page. We did those by hand. So you have to reference that to fill out that little box. All right, let's check it out. How about the domain, range, and horizontal asymptote for the exponential function? The one that we're starting with. Go ahead, Emily.
Negative infinity to positive infinity for the domain, and
Yep.
the range is 1 to negative infinity, and the horizontal asymptote is y equals 1.
Y equals 1. All right, I'm just going to go ahead and switch the range that you said. You said 1 to negative infinity.
I have it right on here.
You do. You read it backwards. That's fine. How did we do with the exponential? Hopefully that's kind of a review because we did that in the last unit. Okay. In this unit, we're looking at logs, which are the inverses of exponentials. So if this is the domain, range, and horizontal asymptote for the exponential, how do those characteristics show up in the inverse? What about the domain, range, and vertical asymptote for the log? Can we list those? Good, Marie?
Domain would be negative infinity to 1.
Yep.
Range would be negative infinity to infinity.
Uh-huh.
And the domain would be x equals 1.
X equals 1. Perfect. So far, so good? 2 thumbs up? All right, so from the previous page, let's see, the equation was log base 3, argument negative x plus 1, and then we had a plus 2 on the outside. Okay, so that was just kind of a copying down from the previous page. The last two columns, we want to analyze this argument a little further. We want to see when does it equal 0 and when is it greater than 0. Remember, we cannot have a negative argument or 0 argument. So we're trying to figure out here, when is it positive? What x values can we plug in? Let's see. So this one, hopefully kind of simple. Subtract the 1, divide the negative. We would get, sorry, positive 1. And then we got to be careful with inequalities. If you subtract the 1 and then divide the negative, what happens? It switches, the sign switches. Perfect. All right. So what did you notice about these values? What might those represent? What do you think, Emily? Yeah?
The horizontal asymptote and the vertical asymptote.
Okay, so the x equals 1 is that vertical asymptote from the log graph. Perfect. X equals 1. And then what about x is less than 1? Good, Rebecca?
It's just identifying the range.
Not quite the range. We said the range was negative infinity to positive infinity.
Sorry, domain.
Domain, there we go. Remember, domain are x values. So x is less than 1. Those are all the x's we could possibly plug in that would work. So far, so good? Perfect. So what we're going to do is just kind of summarize what that big table we filled out yesterday and just now means. So we have different ways that we can identify where vertical asymptote is located. Maybe we have a way to determine what the domain of a log function is, and maybe we have a way to determine what the range of a log function is. So if you have to reference, you might have to flip your page, but in all of those different columns, how did we find the equation of the vertical asymptote of a log? Maybe flip it over and take a look. How did we figure out where the vertical asymptote was located? Yeah?
Setting the argument equal to 0.
There we go. So we're going to set the argument equal to 0. And then we'll solve from there. So by setting it equal to 0, you're figuring out exactly where that vertical asymptote is, okay, on the x-axis. Where is it located? What about how we can determine what the domain of a log function is? Yeah.
Setting the argument greater than 0.
There we go. Set the argument greater than 0 because the argument has to be positive. Good morning. Anything for the office? I think we're good. Thank you. Okay. So they're very similar. We're just going to set one equal to 0 for the vertical asymptote, but greater than 0 to figure out the domain. What about the range of a log function? What do you think, Rebecca?
That always negatives infinity to positive.
Perfect. How'd you know?
It was always negative infinity to positive infinity for the domain of
Exponentials. Perfect. So if the domain for exponentials is always all real numbers, negative infinity to positive infinity, then that must mean the range of logs, because it's the inverse of exponentials, would be the same all real numbers, negative infinity to positive infinity. Perfect. So what we're going to do on this page is just practice identifying these different characteristics about log graphs. Where's the vertical asymptote? What's the domain? What's the range? Maybe we can figure out where the graph is located in relation to the vertical asymptote, meaning are we to the right of it or to the left of it? Remember, for exponential functions, we were either above the asymptote or below it. If we flip that concept, because we're dealing with inverses, we'll switch that idea. We're either to the right of the asymptote or to the left of it for these log equations or these log graphs. So let's take a look at our first one. Equation of the vertical asymptote. We're going to go ahead and set the argument equal to 0. And we'll solve for x. I think we can do this. Pretty simple. Can we get 2? Okay. Let's check out the domain. Very similar idea. but instead of equaling it to 0, we need it to be greater than 0. Some positive number. The argument has to be positive. So if we subtract the 2 and then divide the negative, be careful, that sign's going to switch. We got x is less than 2. Now you could leave the domain written this way, x is less than 2, but I know some of us might prefer interval notation, like with the infinities and parentheses or brackets. So is there a way we might be able to represent this using an interval, just for those of us that are more comfortable with that? Yeah.
It would be negative infinity to 2 since all the x values are less than 2.
Are less than 2, right. So you're going to go all the way to the left on a graph towards negative infinity, but if the vertical asymptote's at 2, that's where we're going to stop, and you cannot touch the vertical asymptote, so you need a parenthesis. Now you can leave it as x is less than 2, but just be aware that it would look like this as an interval notation. They mean the exact same thing. All right. What about the range of that log equation? What do you think, Marie?
Negative infinity to infinity.
Always. Yep. All right, so let's try this last one. Kind of critical thinking here. We know the vertical asymptote is located at x equals 2. We want to try to figure out, are we to the left of that vertical asymptote or to the right? Can we figure it out? What do you think?
Would it be the left since the leading coefficient's negative? Or the negative outcome?
Not. So you're kind of doing that concept with, remember the exponentials where we're either above or below. So maybe that means left or right? Do you know what? I think it's actually going to work out that way. That's not what I was looking for, but I think that's going to work out. Okay? Was there another way we can think about it? Yeah.
Wouldn't it be since x is less than 2?
Okay, so maybe we'll see if Emily's idea works out. For these two examples, I think it is. But she noticed how the leading coefficient was negative. And for exponentials, that meant that we were below the asymptote. For these logs, that must mean we're to the left, which is kind of another negative direction. Like instead of being down, we're to the left. So I wonder if that's going to work out. For this one, it does. Ashlyn noticed the domain. Notice how all the x values that we said would work are less than 2, meaning smaller than 2, meaning to the left of 2. So that's also telling us where the graph is located. So we'll say left because maybe we'll abbreviate leading coefficient as LC. But we'll also say and the domain was less than 2. I'm interested to see if that leading coefficient one works out. We might have to call that the Emily theory or the Emily postulate. Okay? Let's try the next one. Equation of the vertical asymptote. Do you guys want to try this one on your own? All the different characteristics? I think we can do it. Give it a shot. right, let's see how you did. If we take the argument and set it equal to 0, where's our vertical asymptote located? What'd you get? Yeah? 3 halves, 3 over 2. Perfect. Let's check out the domain. We need that argument to be positive in order for the log to actually have a value. So we'll set it greater than 0. What's our domain? Yep.
X is greater than 3 halves.
X is greater than 3 halves. All right. Range of this log function. It's a natural log, but it's still a log. Good, Ashley? Perfect. All right. And are we to the right of that asymptote or to the left? Yes.
Right, since X is greater than 3 halves.
All right. So right because the domain is greater, meaning to the right of that 3 halves. But you might also look at the leading coefficient. I think it's going to work out for this one too. If you wanted to, you could move the -3 to the end of the log if you'd prefer to have it written that way. Notice how the leading coefficient would be a +1. So using that idea or concept from the exponentials, this graph would need to be to the right, that positive side of the asymptote. So maybe we'll say, and possibly because the leading coefficient is positive. Maybe we'll specify that for the other one too. Left because the leading coefficient is negative and the domain was less than 2. So you could write both of those facts, you could write one of those facts, you just need something there as your justification, whether you're to the right or to the left. All right? So with these characteristics in mind, okay, asymptotes, domains, and ranges, we're going to go ahead and take a look at some kind of free response type questions with tables and graphs and functions galore. All right, so the table pictured below are some values of this exponential function. So we're going to use the equation perhaps and the tables to help us with some of these questions. What is the equation of the horizontal asymptote for the function f of x? Notice how f of x is an exponential, so it should have that horizontal asymptote. Can we find it? Go ahead, Marie.
The horizontal asymptote at -3.
How'd you know?
Because as the graph goes left.
Okay, so because the left end behavior approaches -3. Is there a different way you could have perhaps found that value? Maybe instead of using the table, is there a way you can figure out the horizontal asymptote from the equation they gave you? Yeah.
At the end, C.
At the end, that C value, right, -3 on the end. So you could have said because of the left end behavior from the table, or you could have said the C value from the equation. Okay, either way, it's still the same idea or same number. Is the graph of f of x above or below that horizontal asymptote? We'll just stick with that question for right now. What do you think? Yeah.
It would be above because in front of the E there would be a 1 there.
There we go. Above because that leading coefficient, or A value, I know we referenced it as A in the last unit, the leading coefficient is positive for the f of x equation. Okay, positive for f of x. When the inverse function is graphed, meaning the log function, okay, the inverse of an exponential, will that graph be to the left or to the right of its vertical asymptote? Explain your reasoning. If the exponential is above, where do you think the log graph would be? What do you think, Rebecca?
To the right,
Because?
well, it had a positive leading coefficient.
Mm-hmm. So if this had a positive leading coefficient, that means if you were to switch the variables and solve for y like we did yesterday, that log equation would also have a positive leading coefficient. So we could say right because the log equation would also have a positive leading coefficient or positive a value, however you want to reference it. Maybe you wanted to say it would be to the right because the exponential was above, and those are both positive directions on a coordinate graph. Okay, another justification. That would work out as well. Let's see, what is the equation of the vertical asymptote for the inverse, aka the log graph? Where is that vertical asymptote located? What do you think, Marie? How'd you know? There we go. All right, so we're going to have to start being specific with what type of asymptote we're referencing. I know when we were doing exponentials, most of us just wrote horizontal asymptote at 2, horizontal asymptote at 1. Now that we're talking about inverses, like exponentials and logs, I want you to reference the variable. Okay? Horizontal asymptote means you have a y value, whereas a vertical asymptote is an x value. You have to be specific. Okay, so vertical asymptote at -3 because the horizontal asymptote was at y equals -3. All right, let's try some domain and ranges like we did in the table from yesterday and the beginning of today. So we're looking at the domain and range for f of x, which was the exponential they gave us at the top, but maybe we can also determine the domain and range of the inverse, which would be the log graph or equation. Let's perhaps start with the exponential, the one that they gave us. What's the domain of an exponential graph or function? How far left can it go? How far right can it go? Go ahead, Rebecca. Perfect. All right, now let's talk about the range. We have an asymptote to be aware of and whether we're above or below it. What do you think, Ashlyn? Perfect. All right. We had that horizontal asymptote at -3, and we said we were above it, so we should go off towards positive infinity. How do these domain and range intervals from the exponential relate to the domain and range intervals for the inverse, aka the log? What do you think, Ashlyn? Go ahead. They switch. Perfect. So the domain would be -3 to positive infinity. Notice how we said it should be to the right of that vertical asymptote. So we'd go off towards positive infinity as well there. And the range for logs forever and always, -infinity and positive infinity. Perfect. How are we doing so far? Pretty good? All right. Let's try the next one. Find the equation for the inverse, meaning we're going to find the log equation because we're starting with that exponential. So they give us the exponential at the top. In order to figure out the equation, like we did yesterday, we're going to go ahead and switch those variables, the whole idea of an inverse. So x's turn to y's, y's turns to x's, and we have a little bit of solving from there because we want to get the y variable all by itself. What do you want to move over first? Yeah.
Add 3.
Add the 3. So we have x plus 3. What do we want to move over next? We can't move the y or the -2 because those are kind of trapped in the power spot right now. We have to move that e over. What does that become if we move it to the other side? Yeah. a natural log. So natural log of x plus 3. And last but not least, we'll go ahead and add the 2 over. Since we got the y variable all by itself, we're good to go, we're done, but we're going to just go ahead and quickly rewrite it, identifying it as an inverse. Good practice from yesterday. Good job. Last but not least, we identified all these different characteristics about this log equation. Let's go ahead and see if we can graph it. Now, we do know at least one characteristic. We said that we should have a vertical asymptote at -3. So maybe we'll go ahead and label that in. And we also know that our graph should be to the right of that. But we need some points on there to kind of help us connect the dots or get our shape. Where do you think those points are going to come from? What do you think, Rebecca? The table. All right, so the table at the top, these are the points on the exponential graph. What do we have to do to these points to get the points on the log graph? The whole idea of an inverse is to switch, right? So on our graph, we need an x value of -2.99999 and a y value of -5. So that's going to be really, really close to our asymptote, somewhere right there. We'll go ahead and switch all of the other ones. So another point really close to -3, but this time we're at -2. We switch the third point. We'll be on the y or the x-axis. These are just rough. We just need to get a rough shape of our graph. The fourth point should be pretty easy for us to plot. We have -2, 2. Let's see, then we have almost 4.5, and then 4. And the last one, there's no way we can graph it because we don't go all the way out to 51 or 52. So just plotting those points, connecting the graph. There's our log graph. Not too bad. The whole idea of an inverse, we got to switch those variables in the equation, in the table, everything. Everything switches. All right, let's try another one. Very similar. The table pictured below is, let's see, some values from this exponential function. Use the equation in the tables to help you. All right, what is the equation of the horizontal asymptote? What do you think, Marie? How'd you know?
Because c equals 3 and also as x approaches, as left and b.
You could say either one. Okay, so the c value is 3 from the equation of f of x. You could say the left end behavior approaches 3, either one. All right, so is this exponential, bless you, is this exponential graph above or below this asymptote we just identified? What do you think, Hannah?
Below, this is only the
There we go. That a value or leading number is a -1 out front because leading coefficient is negative. Perfect. All right. So, using that information, when it comes time to talk about the inverse, aka the log, would that log graph be to the right or to the left of its asymptote? Let's go ahead and try to find that one as well. What do you think? Yes, Ashley? How'd you know? All right, because, there we go, because the leading coefficient for the log equation would be negative also. We'll eventually confirm that in part E when we actually find the equation. Okay, we'll be on the lookout for that negative out front. but at least we know that's something to be on the lookout for. All right, what is the equation of that vertical asymptote? We know we're to the left of it, but what are we specifically to the left of? Where's that vertical asymptote located? Yeah? How'd you know? There we go, because the horizontal asymptote is at y equals 3. We're on a roll. All right, domain and range for f of x, which was the exponential, and then the inverse, which would be the log. How about the domain of an exponential? Good, Marie? Perfect. Negative infinity to 3. Perfect. We said we are below that asymptote. So we go all the way down towards negative infinity, and then we stop at that asymptote of 3. Perfect. So domain and range for the exponential are wonderful. How do those relate to the domain and range for the log, aka inverse? Yeah. Yep. There we go. They just switch. Whole idea of an inverse. I feel like we're breezing through this. Is that okay? All right. Let's try the last one. Find the equation for the inverse. So using the exponential at the top, we're going to go ahead and switch all of the variables. X's become y's, y's become x's, but we want to try to get that y all by itself. What do you want to move over first? Yep.
We can subtract the 3 over.
Let's do that. We'll move the 3. And then, yep,
Divide the negative.
divide the negative. And then, yeah,
Make it a log with a base of 2.
perfect. Yeah, and then subtract the 2. All right, we got the y variable all by itself. We'll go ahead and replace it with the inverse f to the negative first. Now, here's something we got to pay attention to, okay? In part B, we said that it would be left because the leading coefficient of the log would also be negative. Did we have a negative out front? No. All right. So it looks like sometimes it follows that pattern and sometimes it doesn't. Okay? So we might have to go back and change our justification here because it looks like that was not the case. So maybe we'll say it's to the left because, we'll go ahead and erase that because that was not correct. We thought it would be, but it looks like this one didn't follow it. Left because the exponential was below its asymptote. So if the exponential is below its asymptote, aka kind of a negative direction, then the inverse or the log would have to be to the left of its asymptote, which would be another negative direction. So the leading coefficient might be a clue, okay, but we might not be able to use it as a justification because notice how it's not always the case. Do we see that? Okay. Last but not least, let's go ahead and see what this log graph looks like. So they give us some of the ordered pairs on the exponential graph. We got to switch those ordered pairs to get some points on the log graph. Maybe we'll first identify the vertical asymptote. We said that should be at 3. And we also know it should be to the left. So if we plot some points, let's see, 2.969, comma -7. Let's see, 2.75, comma -4. 1, comma -1. And I think that's all we have, because then the numbers start to get really big. So just connecting those dots and going to the left, we'll go ahead and make our logarithmic curve. Remember, logs kind of look like exponentials, how they're curved in some drastic direction, because they're inverses, they're related. How we doing, guys? We're gonna call it a day? Sound good? All right, that's it for this unit. Okay, logs, how we feeling? Not too bad? Perfect. Tomorrow we'll have a free response day, some more practice with these logs, and then Thursday we'll have a partner quiz. All right?